start कर सकते हैं. Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have started a series where we are discussing top 30 questions of all the high weightage chapters, right? So these questions are very similar to the questions that are asked in your KCET exam. So you can have after you complete, I have also a video where we have discussed what to study in these chapters. So we have completed the recent video for electrochemistry. So you have to watch that video, revise the concepts, write down the formulas, learn all the concepts, and then you have to watch this video and you have to solve the 30 questions that are here. Okay. So if you are able to solve this, you can assure yourself that electrochemistry chapter is ready for the exam, right? Okay. So I want you to try all these questions by your own, and then you can refer to this video for your reference. Okay. Fine. So let us start with the first question. So I'll be also telling you which concepts or which particular topics are more important under electrochemistry chapter. Okay, fine. So the first topic is galvanic cell. Okay, we have already discussed that there are two types of cells, galvanic and electrolytic. So the first one is for the spontaneity of a cell which is correct. So I have told you for spontaneity delta G should be negative, right? This is the only condition. So the correct answer for this question is option B. Okay, very easy and direct question. In the difference between table also we have written this point. Okay, now coming to question number 2. Which of the following is incorrect in galvanic cell? Okay, oxidation occurs at anode. This is correct. Reduction occurs at cathode. This is correct every time. Okay, anode always and where anode is there, oxidation will take place, and wherever cathode is there, reduction will take place. That is fixed. Okay, then the electrode at which electrons are gained is called cathode. Okay, now this one let us understand in a small diagram. We have, if you remember a galvanic cell, we have this type of setup, right? Here we have, if you remember, I took here zinc and this side copper, and zinc comes out as Zn2 plus, leaving the electrons here, right? And these electrons move and are collected here. So this is my anode and this is cathode, right? So what I can say, the electrode at which the electrons are gained is called cathode. Yes, this is correct statement. You see this one where the electrons are gained, right? That is called as cathode. But you see the last statement, the electrode at which electrons are lost is called cathode. So this one is wrong statement. The electrode at which electrons are lost, from this electrode electrons are lost. So that is your anode. So the correct answer for this question is option D. So the incorrect statement is option D. Now let us go to the next question. So now we have come to electrode potential, next topic. Consider the following electrodes, their concentrations are given. The reduction potential in volts, you have to tell the order. Okay. So you have to remember, reduction potential is proportional to concentration. Okay. So you can see here the concentration is highest for B option, right? Ag 0.1 molar. Then we have 0.01. Then we have, okay, so here it is like this is 0.000001. Okay, just it's little error. So we have 0.1, 0.01, and then 0.001, and then 0.0001, right? So the correct answer for this one will be option A. Okay, as reduction potential is directly proportional to concentration. So B is 0.1, highest concentration, then we have C, then we have D, and then we have A. So please change this one. Okay. So the correct answer for this question is option A. Next. Okay, for C, okay, when reaction is given to you, you have to find out the pH of the solution is nearly equal to. Okay, first of all, you see what data are given. E naught of the cell is given and these concentrations are given, E is given, right? So you can think we have two formulas majorly, one is of conductance and one is of mass deposited Faraday's law, and another is from Nernst equation. So this part will be from your Nernst equation. So you can write the equation like this for this reaction, E of the cell is equal to E naught of the cell minus 0.059, I'll take at 0.6 by 6 is the number of electrons, log of chromium, log of Cr3 plus to the power of 2 whole divided by Cr2O7 2 minus divided by H plus to the power of 14, right? So what is it you see? This is the ion and we have to take only the concentration of the ions, right? I already told you in the while explaining. So on product ions divided by reactant ions. In the product side we have chromium, so that will come in the numerator. Now you see the coefficient is 2, that has to goes to power. This one we should not forget. Many of you forget this part, okay? So you have to keep in mind this one. Now let us put the value. What is E value? E value is 1.067. What is E naught value? E naught value is 1.33, okay, minus 0.01, right? This one we can cancel. 6 electrons are there, so N value is 6 log of, okay, what is chromium 3 plus concentration? Chromium is 15 millimole. So I can write 15 into 10 to the power of minus 3 whole square divided by Cr2O7 concentration is 4.5 into 10 to the power of minus 3, right? Then we have H plus concentration to the power of 14, okay? So now you can solve this one. 0.01 log of, you can say I can write 15 into 15 into 10 to the power of minus 6 by 4.5. So I'll write it as 4 into 10 to the power of minus 3. Then we have here H plus to the power of 14. So if we solve this one, 15, 3, then we have 50, and here I can write it as minus 3. So 0.01 log of 5 into 10 to the power of minus 2. I'll get this value, right? Then we have divided by H plus to the power of 14. This one will be equal to, this whole part will be equal to, can just subtract this one, 1.33. So what I have on this side, 1.33 minus 1.067, okay? So now you can solve this equation, okay? So we can solve it. Okay, so we'll get 0.263 around. Now you can divide this one on this side. So we'll get log of 5 into 10 to the power of minus 2 by H plus to the power of 14 is equal to, this one you can divide on this side, 0.263 divided by 0.01. So we'll get 26.3. So log of 5 into 10 to the power of minus 2 by H plus to the power of 14 is equal to, we'll get 26.3, right? Now what you can do, can just do the this part, I can erase this here, see here, little long calculation this question. Okay, now see this one, can we write like this? This part can we write like this, log of 5 into 10 to the power of minus 2 minus 14 log of H plus is equal to 26.3, okay? Then you can just take the value, solve the equation, and then you will get, you can keep it this value, minus log of H plus, you can solve it. This value will be something near to equal to 2. Okay, so you can just check the calculation. The major part I have done. So the answer for this question will be option A. Okay, fine. Since this is a little lengthy question and you should know what is the relation and how to calculate the pH value. Now let us go to the next question. Okay, so given one cell is there and we have been given with E of the cell, the equilibrium constant. Okay, so I have told you while revising the formulas also, the equilibrium constant, that formula is very important. What is that formula? E of the cell is equal to 0.059 by n log of k, right? So what is E of the cell value? 0.22. Then we have 0.059, we can take it as 0.06. And n value, you can see what is the n value here. N value will be 2, right? So yes, Ag is there. Ag plus is getting converted to Ag. 2 Ag plus you have to take. Similarly here 2H plus also is getting, H2 is getting converted to H plus, right? So here also 2 electrons involved, here also 2 electrons involved. So N value will be 2, that is equal to log of K. So now if you solve this, we'll get 0.22 divided by 0.03 is equal to log of K. See, after this you can know this will come something around 7 point something, this value. So if you take now anti-log on both sides, so K value will be equal to 10 to the power of 7 point something, right? So this value, if you solve further, we'll get 10 to the power of 7 into 10 to the power of something, which we can solve. But we need not solve that. You can see in the options, there is one option which has 10 to the power of 7. So obviously that will be the answer, right? So the correct answer here will be option A. Okay, next question. Okay. So we have been given with a reaction Fe3 plus, this value is given, okay, 2 cells are given, equilibrium constant is asked. Okay, so you can see first write down the reaction, Fe plus 3 plus 1 electron is giving Fe2 plus, right? And see here the reduction potential of Fe3 plus is more, right? So Fe will undergo reduction and I2 will undergo oxidation. So the reaction here will be I minus plus, sorry, 2I minus will give you I2, will produce I2 plus 2 electrons, right? The number of electrons should be balanced, so we have to multiply this also. So now you can add these reaction. So we will get 2Fe3 plus 2I minus is equal to 2Fe2 plus I2, right? So now we can write the cell reaction, that is your E of the cell 0.06 we can take for easy calculation. Number of electrons is 2 log of K, right? Now here one thing you can see, what is the E naught of the cell? E naught of the cell is E naught of cathode minus E naught of anode, right? Now how to know which is cathode and which is anode? The one whose reduction potential is more, definitely that will be the cathode. So if you compare 0.76 and 0.55, 0.76 is a higher value, right? So that means this one is cathode, Fe will behave as cathode and I2 will behave as anode, right? So now if you solve this, we'll get 0.21, right? So we can write it here 0.21 here, that is equal to 0.03 log K, or I can write log K is equal to 7, or 10 to the power of 7 is K. Okay, so the correct answer for this one is option D. So you know, whenever you take anti-log, whatever is the value on the other side, that becomes to the power of 10. Like suppose it is 7, it will become 10 to the power of 7. So we'll get this is as the answer. So you can see from equilibrium constant, this type of questions are generally asked. Next, okay, for a cell involving 2 electron changes, means N value is 2. Okay, E naught of the cell is given to you. Calculate again the equilibrium constant. Very similar question. E naught of the cell is equal to 0.06 by 2N is equal to 2 log of K. So this one is 0.03. E naught of the cell is 0.3. So we can write like this, log K. So log K is equal to 0.3 by 0.03, right? So we can write it as, so this value will be 10. 10 is log K, right? Then what will be the value of K? So I just now I told you, if you want to take anti-log on both sides, whatever is present here, you have to take 10 to the power of that number. So if it is 10, means the answer will become 10 to the power of 10. So the correct answer for this question is option D. Okay, next is Faraday's law. So you have seen 3-4 questions on equilibrium constant. Now we have Faraday's law question. 1 liter of MgCl2 is electrolyzed completely, passing a current of 1 ampere for 16 minutes and 5 seconds. So what all data are given to you? First time, what is the current value? I is 1 ampere. Time is, see, 16 minutes and 5 seconds, means total 965 seconds, right? Next, original concentration of MgCl2 solution was So we have to just calculate how much magnesium chloride is first deposited, right? So we have this formula, M is equal to Z into I into T, and what is Z? Molar mass by N into 96500 into I into T. Now what is molar mass here? Molar mass of magnesium is 24 divided by 2 into 96500 into I value is 1 ampere and time is 965, right? So now if you do this one, so we'll get 12 by 100. So this is what mass. This is the mass deposited. But we are not, it is not asked to calculate the mass deposited. It is asked original concentration, and you can see the units are in molarity, right? So the question is, we have to find the molarity of this one. Means whatever magnesium was present, that all got deposited. So what was the original concentration? So if you want to calculate, let us first calculate number of moles. Number of moles will be given mass by molar mass. So that is 1 by 200, right? Now we can take molarity formula is number of moles, right, divided by volume. Volume is given to you as 1 liter, right? So this is 0.5 into 10 to the power of minus 2. Okay, we can't find any option like this, but we can write this as 5 into 10 to the power of minus 3, right? So the correct answer for this question will be option A. So in this question, the trick was, we already know how to use the Faraday's law, but the language of the question, what they have asked you, is little different. It is not directly asked how much mass is deposited, right? After you get mass deposited, you also have to calculate the concentration. There you can see the options are in molarity, so we have to find the molarity. Okay, fine. Next, the charge required for the reduction of 1 mole of MnO4 minus to MnO2. So what is the MnO4 minus 2 MnO2? The oxidation state of manganese here, X minus 8 is equal to minus 1. So X is equal to plus 7, right? Here it is plus 4, right? So from plus 7 to plus 4, how many electrons will be needed? 3 electrons, 3 moles of electrons. So 3 moles of electrons means 3 Faraday. So the correct answer for this question is option B. Next, by again similar question, by passing electric current, NaClO3 is converted to NaClO4 according to the following equation. Okay, how many moles of NaClO4 will be formed when 3 Faradays of charge is passed? Okay, so what it is telling, we have NaClO3. Okay, when you pass current through this, it is getting converted to NaClO4, right? Now if you give 3 Faradays, then how much NaClO4 will form? If the charge given is 3 Faraday, then how much NaClO4 will be formed? That is the question. Okay, now let us see this one. Can I write like this? ClO3 minus, and this one can be written as ClO4 minus. Okay, so let us just calculate the oxidation state. We have, we'll calculate the oxidation state of chlorine. So, okay, we can take the whole molecule and calculate. So, NaClO3 to NaClO4. Oxidation state of this one's plus 1. Chlorine we have to find out. So X minus 6 is equal to 0. So X is equal to plus 5. So chlorine here is plus 5. And here if you calculate, sodium is plus 1. X minus 8 is equal to 0. X minus 7 is equal to 0. So X is equal to plus 7. Here chlorine is plus 7, right? So from plus 5 to plus 7, it is 2 Faraday, right? So that means what? Using 2 Faraday, we can convert 1 mole of NaClO3 to NaClO4. Now if you use 1 Faraday, it will be half mole, right? Now if you use 3 Faraday, according to the question it is 3 Faraday. So for 3 Faraday we will require 1.5 moles. So 1.5 moles of NaClO3 can be reduced, then 1.5 moles of NaClO4 will be formed. So the correct answer for this question is option C. Okay. Okay. Next, the amount of current in Faradays required to the reduction is given. Okay, Cr2O7 to Cr2O72 minus, this example is asked many a times. So see properly, we have Cr2O72 Cr3 plus. So first of all, you have to see the chromium is not balanced, right? Here we have 2 chromiums and here we have 1 chromium. So we have to balance it. Okay, the other part no need, you have to just think for chromium. So what's the oxidation state of chromium here? 2x minus 14 is equal to minus 2. So we will get x is equal to plus 6. And here it is plus 3. So what does that mean? 1 chromium is going from plus 6 to plus 3. So what is the charge involved here? 3 Faraday, right? But in the question it is Cr2O7, means 2 chromiums are there. So for 2 chromiums it will be into 2, that is 6 Faraday. Okay, so the correct answer for this question is option C. Okay, next. How many coulombs of electricity are required for the oxidation of 1 mole of water to dioxygen? So we know when 1 mole of water is undergoes oxidation to give you dioxygen, we get 4, for 2 moles of water we have 4 electrons, right? But so that means for 1 mole of water, I am not writing the complete reaction, you can see for 2 moles of water 4 electrons are used. So for 1 mole, that means 2 moles of electrons will be used. 2 moles of electrons means 2 Faraday. If you convert it into coulombs, so 2 into 96500 coulombs, because 1 Faraday is 96500 coulombs. So if you solve this, we'll get, right? So we'll get 1.93 into 10 to the power of 5. So the correct answer for this question will be option D. So this reaction will be there in the fuel cell part also. So you have to see this reaction properly. Next. Okay, very theory based question. A device that converts the energy of combustion of fuels like hydrogen and methane directly into electrical energy. So this is the work of fuel cell. Okay, correct answer is option D. Okay, next. Okay, so I told you the products of electrolysis are very important. So you can see this during the electrolysis of brine, by using inert electrodes. So brine means we have to, so NaCl is there, right? And we have, so Na plus will go towards the anode, sorry, Na will go towards cathode and Cl will go towards anode, and Cl minus will become Cl2 plus half Cl2 plus 1 electron. So chlorine is liberated at anode. Okay, so this you can remember from that table, products of electrolysis, that table. Okay, next, resistance of 0.1 m weak acid Ha in the conductivity cell is given. The cell constant is also given, lambda naught m is also given. You have to find the pH of the solution. Okay, so first of all, it is a weak acid, right? Ha. When it dissociates, we get H plus and A minus. Okay, suppose the concentration of Ha is 0, Ha is C initially, this one will be 0 0. Then from this C alpha part gets dissociated. Then how much H plus will form? C alpha, right? So what I can say, concentration of H plus is C alpha, right? So first of all, our task is to find the concentration of C alpha. Or first is to find the concentration of H plus. From that we need C and we need alpha value. But if you see, C value is given to you 0.1, right? So our task is to find alpha value. So how to find alpha value? We'll go from backward. Okay, how to find alpha value? We know alpha formula is lambda m by lambda naught m. Lambda naught m value is given to you. So we have to find lambda m value. So how to find lambda m value? That is kappa into 1000 by C. Again, concentration is given to you, but we don't know the kappa value. So we have to find first kappa value, that is 1 by R into L by A, that is cell constant. So we can write down what is R value here, 2 into 10 to the power of 3, and L by A value is 0.78. So we'll get 0.39 into 10 to the power of minus 3. That is kappa value. Now if you substitute here lambda m value 0.39 into 10 to the power of minus 3 into 10 to the power of 3 by C is 0.1. Okay, so you can solve this part. Okay, so we can cancel this one. So we will get 3.9, right? So if you solve this, yes, 3.9 will get. Next what we can do, so we got now kappa value. Okay, after getting kappa value, we'll substitute here to find out lambda m value. So lambda m will be equal to, okay, lambda m I found out 3.9, right? So now you find the alpha value. So what is alpha value? Alpha value will be 3.9 by 390, right? 3.9 by 390. So how much it will be? We will get 1 by 100, right? Alpha value is 1 by 100. Then we have to find C alpha value. So C alpha value will be, okay, see here, C alpha value will be 0. What is the concentration given? 0.1 and 10 to the power of minus 2. So we'll get 10 to the power of minus 3. So this is my H plus concentration. Okay. So if you take pH value, we will get 3. Okay. So the correct answer for this question will be option D. Once again, we'll discuss this question, little lengthy one. Okay, see here. First, see what data are given. This is your resistance, that is 2 into 10 to the power of 3. Then you are having cell constant, that is 0.78. You have been asked the concentration of HA, H plus, right? H plus from a weak acid, the concentration is C alpha. Okay, so first of all, we need to find C value is given 0.1 and alpha value is there. Okay, so first our task is to find alpha value. What is alpha formula? Lambda m by lambda naught m. So next is to find lambda m value. So lambda m value, what to find? Kappa into 1000 by C. We don't have kappa value also. So next is kappa value 1 by R into L by A. So let us start from here. 1 by 2 into 10 to the power of 3 into 0.78. So we'll get 0.39 into 10 to the power of minus 3. That is your kappa value. Substitute here for lambda m. That is 0.39 into 10 to the power of minus 3 into 10 to the power of 3 divided by C is 0.1. Okay. So again we will get 3.9. We got molar conductivity. Next we can find out alpha value. So that is what is we can find here. Alpha value is 3.9 by 390. That is 1 by 100.01. Then what is H plus concentration? C alpha, C value is 0.1, alpha value is 0.01. So we'll get 10 to the power of minus 3. So pH will be minus log of 10 to the power of minus 3. That is your plus 3. Okay. So the correct answer for this question is option D. Okay. So yeah, this direct question, but a lot of steps are involved in this. Next. Okay. NaF is there. Aqueous solution is there. Then what will be produced at anode? So you can see here we have Na plus F minus and aqueous solution H plus and OH minus. So these all will go towards your cathode. Okay, and this part will go towards anode, right? So at anode oxidation will take place. You know, fluorine oxidation potential is very low, so it will not undergo oxidation. OH minus will get undergo oxidation to give you O2. So the correct answer for this one will be option C. Okay. Next. Okay. So we have aqueous solution of copper sulfate, which is given electrolysis. The pH of the solution will be. Here also you should little know about the data. See, H plus reduction potential is assumed to be 0. Copper 2 plus reduction potential is assumed to be, the value is 0.34, right? So now if you are taking an aqueous solution of copper sulfate, H plus will also be there, copper 2 plus ions will also be there. So the one whose reduction potential will be more, that will get reduced. So out of H plus and copper 2 plus, I can say copper 2 plus will undergo reduction, right? Then in the solution what will be there? In the solution H plus will be there, right? So in the solution H plus is there and H plus is undergoing a reduction to produce H2. Okay, So that this reaction is not happening. H plus will be remain in the solution. This H plus will remain in the solution and it will not undergo reduction till the copper 2 plus is there, right? Because copper 2 plus reduction potential is more. Now, so can I say in the solution H plus concentration is increasing? In the solution H plus concentration will increase because copper 2 plus will undergo reduction. So if H plus concentration is increasing, pH will decrease, right? So what will happen to the pH? pH of the solution increase is wrong, remains unchanged is wrong, it will decrease, right? So the correct answer for this question is option C. So once again listen here, you have two things, one is H plus and one is copper 2 plus. Copper 2 plus, you should remember its reduction potential is more than H plus. So out of these two, copper 2 plus will undergo reduction, H plus concentration will remain in the solution. Now if H plus concentration is there, it will increase, pH value will decrease. So the correct answer is option C. Okay, next. Okay, again from the products of electrolysis, which of the reaction will occur at anode? Again anode is there. So we have Na plus and Cl minus, H plus and OH minus. So these two will undergo oxidation at anode, but we have already seen in the table chlorine undergoes oxidation to give you Cl2. So the correct answer for this question is option A. Next. Okay, so now we have come to conductance. In the dry cell, which of the following is an electrolyte? Okay, so dry cell we have seen in that the electrolyte used is your ammonium chloride. Okay, so please remember this one. The ammonium chloride is used as an electrolyte. Direct question. Okay, next. Specific conductance of 0.1 m HNO3 is given to you. The molar conductance of the solution is. This is direct formula based question. Molar conductance is asked. So lambda m is equal to kappa into 1000 by C. What is the value of kappa? 6.3 into 10 to the power of minus 2, 10 to the power of 3. C is 0.1, right? So I can write 6.3 into 10 by 10 to the power of minus 1. So if you solve this, we'll get 630. So the correct answer for this question is 630. This is easy and direct formula based question. Next. Molar conductivity of is maximum for which of the concentration? So again you just see the formula. Lambda m is equal to kappa into 1000 by C. So molar conductance is inversely proportional to C. If concentration is less, this one will be maximum. So you see in all this option, the concentration is least for option B. So the correct answer for this question is option B, right? Okay, next. Okay, this is given. Resistance of a 0.01 m KCl solution is 1500 ohm. If the conductivity of 0.01 m KCl solution is this much, the cell constant is how much? Okay, first you have to write the formula. You see what data are given to you. Conductivity is given. Then we have resistance is given. Concentration is given. We know this formula. Kappa is equal to 1 by R into L by A, right? Now what is 1 by R? What is the resistance value given? 1500, and L by A we have to find out, that is cell constant, and kappa value is 0.1466 into 10 to the power of minus 3. So we have into 10 to the power of minus 3 into 15 into 10 to the power of 2. 1500 I can write like this. So if you solve this, we'll get the correct answer for this question is option A. Okay, 219, you can solve it and check. Okay, so this is also direct formula based question. Next. Okay, this is important one. Okay, so in my revision video also I have told you how to decide type of electrolyte. Suppose we have NaCl, this is +1, this is +1, so this is 1,1 type of electrolyte. KCl, this is +1, this is +1, so this is also 1,1 type electrolyte. So both of their A factor will be same. In the D by Onsager-Haskell equation, if the electrolytes are of same type, their A value will be same. Okay, so the question here is, the pair of electrolytes that possess the same value of the constant A in the d by Huckel equation is. Okay. So what we can do, we can check all the equations, all the options, and let us see they are of what type. So I'll do for all the options. Okay. See here, NH4Cl. This is NH4 plus and Cl minus. So this is 1,1 type. And this is also Na plus and Br minus. So this is also 1,1 type. Next is option B. You see Na is plus 1, Br is minus 1. So this is 1,1 type. But here magnesium is plus 2 and sulfate is minus 2. So this is 2,2 type. You see these two are not of same type. So their A values will not be same. So this cannot be the answer. Okay, now let us see sodium plus 1 minus 1. So sodium is 1,1 type. And calcium, you see this is plus 2 and chlorine is minus 1. So I can write 2,1 type. Okay, so these two are also not of the same type. Their A value will also be not same. Now for magnesium sulfate, we have Mg plus 2 and sulfate minus 2. So that is your 2,2 type. And Na2SO4, Na is plus 1, sulfate is minus 2. So this is of 1,2 type. So again you see these two are also of different type electrolytes. Their A value will not be same. So you see here in the first option, both the electrolytes are of 1,1 type. So the correct answer for this question will be option A. Okay. Fine. Now let us see the next question. At a particular temperature, the ratio of molar conductance to specific conductance of 0.01 mNaCl solution is. Okay. So first let us write the formula. Kappa into 1000 by C. They are asking you the ratio of molar conductance to specific conductance. So I can write lambda by K is 10 to the power of 3 and C is 10 to the power of minus 2. So if it goes up, it will become 10 to the power of 5, right? Now the point is, you see, these two we can eliminate. But here there are two things, but the units are different. So we have to be careful with the units also. So I have also told you what is lambda ms centimeter square mole inverse, and this one is s centimeter inverse. So SS will get cancelled, will get centimeter cube mole inverse, right? So the correct answer for this one is 10 to the power of 5 centimeter cube mole inverse. Okay, so A is the correct answer. Next. Okay, again we came from in fuel cells, DAS are used as catalyst. So in this table also I have mentioned this part. Platinum palladium is used as a catalyst. Okay, so correct answer is option C. Next, a secondary cell is one which, so you know secondary cells are those which can be recharged. Okay, recharged on what? On changing the opposite direction of the current. So can be recharged is correct, but you can see can be recharged by passing current through in the same direction. This is the wrong statement. Can be recharged by passing current through in the opposite direction, cannot be recharged. See, these both the statements are correct. Okay, so answer for this question is either A or C. You can write both A and C, but any option you try, both will be correct. Okay, or you can say most can be recharged by passing current through it in opposite direction is the most appropriate answer, but again both will be correct here. So answer for this question is both A and C. Next. Okay, while charging the lead storage battery, so I have told you among all the cells, this lead battery is very, very important. You have to learn the anodic reaction and cathodic reaction for recharging and discharging process. So if you have remembered, while charging the battery, PbSO4 and anode is reduced to Pb. Please check the reaction. Correct answer for this question is option C. Okay. Next. In a fuel cell, the reaction occurring at cathode. So again, fuel cell and lead cell, I told you to remember the reactions. The reaction occurring at cathode is option number A. Okay. O2 will get 4 electrons to get converted to 4 OH minus. Okay. Fine. Next. For a hydrogen fuel cell at this pressure is 240 kilojoule, E naught for the cell is approximately equal to. Okay. So you see here, we have been given with delta G value is given. Okay, so we have one relation, if you remember, delta G is equal to minus NF E naught of the cell. Now what is the value of delta G? Minus 240. Here you have to be careful about the units. Okay, unit should be in terms of joules. Okay, is equal to, now in this reaction the number of electrons is 2, 96500 into E naught we have to calculate, right? So if we solve this, we'll get minus minus will get cancelled. 240 into 10 to the power of 3 divided by 2 by 96500 equal to E naught of the cell. So you can do this calculation part, and I think the answer you will be getting will be 120. So we have 120 into 1000 divided by 96500. We can cancel these two. So we'll have 1200 divided by 965, right? So if you calculate this one, 240, 193. Okay, so 240 and 193, if you divide somewhere else, you can see both are very close options. So and just check once with division. Sorry. So around 1.24 you will get. Okay, so check this calculation. I think the answer will be somewhere around 1.24. If you have any doubt in this question, you can comment down. Okay. Okay, see, this is very important question and a new type of question which is generally not there in NCERT book. So let us little focus and see this question. See, whenever these type of values are given, you have to use something called as Latimer diagram. Okay, so first of all, you see Mn plus 7 is there, plus 4 is there, and plus 2 is there. So let us draw a diagram like this. Mn2 plus 7 plus 4. You have to write it in decreasing order. Okay, now they have given you the value for plus 7 to plus 2. This value E naught is how much? Here E naught value is 1.5 volt. Then plus 7 to plus 4 E naught value is asked to us. Plus 4 to plus 2 E naught value is 1.2 volt. Right? So we have one formula here. This whole one I can write. This is suppose E3. This is E naught 1. This is E naught 2. Okay. So we have one formula here. N3E3 is equal to, this total is equal to this plus this. N1 E naught 1 plus N2 E naught 2. Right. So now what you have to do, N, what is this N value here? N value is the number of electrons that has to be exchanged, or the difference you can say. So now you see for this one, plus 7 to plus 5, the N value will be 5, that is 7 minus 2, 5. So I can write 5 into E3. What is E3 value? 1.5 volt is equal to N1. So plus 7 to plus 4, what is the difference? 3. So N1 value is 3 into E1 plus N2 is plus 4 to plus 2, so that is 2 into 1.2. Okay, so we will get 7.5 equal to 3E1 plus 2.4. So 5.1 is equal to 3E1. So E1 will be equal to 1.7. Okay, so the correct answer for this question will be option C. Okay. So this is little different question. You can just practice some more questions of this type. Okay. So that's all for this video. So just practice all these questions. If you have any doubt in any question, please comment it so that we can take it in the next video. And if you have liked this video, please like, share and subscribe our channels for your preparation. Thank you.